Hello all, welcome back. So in the last class we have seen the what is the meaning of shift register, then what are the classifications of the shift register. So in this class we will try to understand how to design the shift register, nothing but the 4-bit serial in serial out, or we can call it as the SISO. SISO means input we are giving serially, output we are collecting the serially. Shift register using the D flip-flop operation, right? So from here we need to understand few points so that we can able to design the circuit, right? So if you understand what is the first point, here we need to design what? 4-bit shift register. So 4-bit means it is going to store the 4-bit information, right? As we discussed in the previous classes, each flip-flop can able to store only 1-bit information, right, at a time. So but if you want to store the 4-bit information, how many flip-flops are required? 4 flip-flops are required. The first point to remember is that if you want to store the multi-bit information, we require the multiple number of the flip-flop. In this case, the given question is we need to design the 4-bit shift register. So 4-bit means 4 flip-flops are required. So what is the flip-flop they are asking us to use? They are asking us to use the data flip-flop or delay flip-flop or D flip-flop or transparent flip-flop. Now if you see that why in most probably we used to design by using the D flip-flop, of course we can implement by using JK flip-flop, some other flip-flop also. Then most of the cases we are using to design the shift register by using of the only D flip-flop. So why D flip-flop means, for example, see if I take some flip-flop value 1, flip-flop 1, flip-flop 2, something like this, right? So let it be initial values in flip-flop is 1, flip-flop 2 is 0 something. Now what I want to do is I want to replace this data. So for example, if I am giving 0, now what will be happen? This 0 will move inside of the first flip-flop, right? Now what it will store? 0. But if you observe here, what is the previous value here? 1, right? Now it will become the 2 bits, right? So 2 bits cannot able to store by the flip-flop, right? Now what flip-flop will do is, the moment you are giving the external input to your flip-flop 0, this data will go into the second flip-flop. Now whatever this flip-flop 2 value already it is 0 is there, right? It will give as the output value. This will give as the output value. Now if you observe here, what is the previous data in the flip-flop 1? 1, right? The same data is going here, right? 1 is going, right? It means that your input is 1 means output also should be 1, right? So see that if you are giving input, output should also 1. Same data or same input should be shifted from the one flip-flop to the another flip-flop. In simple way you can remember that your input value should be output value. It means that same value only you are shifting, right? You are not shifting the new value, right? If it is 1 means here also 1 only, right? After shifting, it means data should be same, right? So it means that in which flip-flop if your input equal to output value, the only flip-flop is that we have something called as the D flip-flop or delayed flip-flop. So what do you mean by transparent or delayed or data flip-flop? Means your input value will be output value. It means that same data will be input, the same data will be shifted as the output also. So in that cases we required the D flip-flop operation. Anyway, in the given question they asked us to use the D flip-flop. First point to remember is 4-bit is that 4 flip-flops are required. So for example, I am going to consider the flip-flop 1, then one more is the 2, 3, 4 flip-flop, right? Why? Because we need to store the 4-bit information. So for understanding purpose, I am giving this name as the A, B, C as well as the D. So if you consider D flip-flop, how many inputs we have? D, then we have the clock pulse, then we have the outputs are the Qn as well as the Qn bar, right? So first if I am considering this flip-flop, if you see here, this flip-flop A, this flip-flop B, C, D, all are D flip-flop only, right? For naming convention, what I am going to give, this I am going to DA, this one is DB, this one is DC, this one is DD. So what is the output value? We have QA, QA bar. A means in place of the N we are considering the A, that's it. Next here QB, QB bar, here QC, QC bar, here QD, QD bar. The same thing here you can see that, right? Now see that now we need to connect one flip-flop with the another flip-flop, right? So now before that, what I explained in the previous class, these are the example for the synchronous operation. Means synchronous operation means the same time flip-flop 1 will work, 2 will work, 3 will work, 4 will work, right? So if you want to make the synchronous counter or synchronous circuit, what is the condition? Everything will be depends upon the clock pulse, right? So based on how we are applying the clock pulse, we have the two types. One is synchronous, another one is asynchronous. Now if each time all the flip-flops want to trigger or changes at the same time, means what we have to do is we need to connect the common clock pulse to the all the flip-flops, so that way then it is called as the synchronous counter. So second point what I am going to do is I am going to connect the all the clock pulse for the flip-flop 1, flip-flop 2, flip-flop 3. I am going to give the common clock pulse. Now it is called as the synchronous counter or synchronous operation, right? Now see that now clock pulse has been given. What is the one more thing is pending? So somehow we need to connect the this output of the flip-flop to the here, right? The output of the second flip-flop to the third flip-flop, right? The output of the third flip-flop to the fourth flip-flop, right? Then one more, what is the use of D flip-flop? The same output will be passed to the input. The same value 1 will be passed to next flip-flop. It means that output will be connected to the input. If you see that how it will be connected, one flip-flop to the another flip-flop means the output of the first flip-flop is connected to the second flip-flop. Why means, for example, if the first flip-flop output equal to 1, let it be 1 is stored here. After performing the shifting operation, now what will be happen? So through this line what will be happen? This output will be input, right, for second flip-flop. So this way this is the DB, this is the QA. It means that first flip-flop will be output will go to the second flip-flop input. The same way second flip-flop will output will go to the input for the third flip-flop. So it means that we are connecting here, we are connecting here. Then it is called as the serial in, serial out shift register, right? So this is a circuit diagram. The same circuit diagram here you can observe, right? So see that how many flip-flops I am going to consider: first, second, third, fourth, something like this, right? So if you understand easily, what we will do is this is Q3, or in other way you can consider this is QA, QB, QC, QD, something, right? So now if you are considering like this should be a flip-flop, right? So DA, DB, DC, DD, something, right? Now see that for the serial in, what is the meaning of serial in? So input we are giving something like this, right, for first flip-flop. Output also we are getting something like this, right, serial out, right, as we discussed in the previous classes. So where is the final flip-flop? Fourth flip-flop, this one, right? So the output of the QD or Q4 is the shifting towards the output. It means that serial output value. But where we need to give the input? The input will be always given to the first flip-flop, right? What is the first flip-flop value? DA, right? So here only we are giving the data in, right? So data in means we are giving some external value. After giving some external value 1 or 0, it will come to here. This data will be sent to here. This data will be again sent to here. This data will be again sent to here. That operation we will see, right? So as point of this time you need to understand this 4-bit means we require the 4 flip-flops. Which flip-flop? D flip-flop. D flip-flop means the input will be equal to the output value. Now what is the operation they are trying to implement? So serial in, serial out. Serial means like this, serial out means also like this. It means that shifting also in horizontal only. So here if you observe here, so shifting also in horizontal only. So these are the example for synchronous, right? Synchronous means the common clock pulse, you try to take the negative edge. The synchronous means common clock pulse will be applied to the all the flip-flop, right? Now we will see the operation of this serial in, serial output flip-flop, right? So by considering the some use cases or example. For example, let it be what is the requirement I am going to consider. If you read this one, let consider that all flip-flops output having the data of 0 0 0. What is the meaning of this one is the flip-flop value which is stored initially is 0 0 0. Now what is my requirement is that I need to replace all zeros with the all ones. By using which mechanism? I need to give the input serially. Shifting also should be performed serially. Output we need to collect the serial output operation, right? So if you understand, as we discussed previously, D flip-flop is used because same information is stored, as well as the we need to perform the shifting operation. After shifting also the same input only will be going to the output, or same output will be going to the input. It means that flip-flop input will be equal to the output value. Now what is my requirement? What is the initial value stored in the flip-flop? 0 0 0 0. Now what is my requirement? I want to replace this all zeros with the all the 1 by using of which operation? Serial in, serial out operation. Now we will see how to implement this operation, right? Right. So what is the first count value we have? The first count value before applying the clock pulse is the something 0. Fine. So what is the value that right? So what first value is something like we'll consider before applying the clock pulse. It means that initially before applying the clock pulse, we'll consider counts. What is the value stored in the flip-flop? The value stored in the flip-flop is 0, 0, 0, 0. Let it be, this is the A flip-flop, B flip-flop, C, D, something like this. It means something I'm going to take QA, QB, QC, QD. Or you can consider Q3, something like this. Q3, Q2, Q1, Q0 also you can consider, that is your wish, right? So here they have considered D3, Q3, D2, Q2, whatever it may be, that naming convention can be any, right? Otherwise you can consider only DQ also, that is up to you, right? So let it be, I'm going to consider first flip-flop something like this. So the value is A, so I'm considering this is as DA, this is as QA. B flip-flop means DB, QB, next DC, QC, C flip-flop. Next D flip-flop means DD, QD, right? So here just I'm going to mention the output value. It means that before performing the serial and serial output operation, the value which is stored in the all flip-flop is 0, 0. It means that before applying the first clock pulse, the value is, initial value is 0, 0. Now what is my requirement? I need to replace with what? As we discussed, 4, 1, right? So now see that where we are giving the external input value, the external value we are giving at the DA only, right? So here only we need to pass the external input value. Now as we discussed in the so many times, serial means one after another. It means that how many bits we have? We need to finally replace with the 4 bits, right? But at a time we cannot able to push the 4-bit value into the single data input value, only one at a time. That is the meaning of serial. But in case of parallel means we can push the all these 4 data information into the 4 flip-flop at a time. Remember simple point, serial means one after another, parallel means at a time. Now if you want to give this data externally, you cannot able to pass all 4 ones at a time. Only first time for first clock pulse single one, after second clock pulse single one, third clock pulse single one, fourth clock pulse single one. Like this you can pass, because it is the serial operation, not the parallel operation. First point to remember is before applying the anything or clock pulse, the value stored in the flip-flop is the 0, 0, 0, 0. Now what I am going to do is I am going to apply the first clock pulse value. As we discussed, after applying the clock pulse, the count will be shifted from the one value to the another value, right? Now what we are trying to do here is, after applying the first clock pulse, what is the LSB value? This one, right? This means this one, right? This one we are going to give here. Data, external data 1 is we are going to give here. Now what is the operation performing after applying the clock pulse? Shift operation, right? Shift operation means what will be happen? This 1 will go to here, right? Now what is the value stored in the flip-flop? 1. Then what about this value? So here we have the connection, right? So this 0 will go to here. Now what about this 0? This 0 will go to here. Now what about this 0? This 0 will go to here. Now what about this 0? This is important. This is we cannot able to store because we don't have the next flip-flop. So this 0 we are collecting as the serial output manner. It means that serial output manner. Now what is the data replaced after applying the first clock pulse? 0, 0 is replaced with what? 1, 0, 0, 0. It means that we are giving some external value. So this one will consider some external value, nothing but this value. After giving one, what will be happen? This one we going to this one. External input 1 is going to inside of this flip-flop, nothing but QA. This 0 will going to here. This 0 will going to here. This 0 will be going to here. This is nothing but your final output value, which is collected in the serial manner, means serial output value, right? Now after applying the second clock pulse, what will be happen, right? So see that after applying the first clock pulse, what is the value it is turned out? 1, 0, 0, 0, this one. After applying the second clock pulse, what will be happen, right? So the second clock pulse means this one already completed, right? Now we are trying to give this one, right? 1, right? Now this data we are giving here, right? Now what will be happen? This is the answer. So this one will go to here, right? What about this one? Already here, what is the value is there? 1, 0, 0, 0, right? This one will go to here, right? Then what will be happen? This 0 will go to here. This 0 will go to here. This one will be final output. It means that after applying the one more clock pulse, you can insert the one more external data, right? That is nothing but the 1, right? Now what will be happen? This 1 will come to the external data inside of your first flip-flop. The first flip-flop will move to here. The second flip-flop will be moved to the third flip-flop. Third flip-flop will move to the fourth flip-flop. The fourth flip-flop is nothing but your output value, because it can able to store only 4 values, something like this. Now what it is saying? 1100. Now after applying the third clock pulse value, what is the external value we need to pass here? See, serial means always we need to pass the external. At a time we can able to, out of 4 ones, at a time we can able to pass only 1. For first clock pulse this one, second clock pulse this one, third clock pulse one more 1, fourth clock pulse one more 1, because serial means one after another. At a time you cannot able to pass the all the value, right? So now I'm going to consider the third clock pulse. I'm giving this value, nothing but this value, right? Third value I am giving, that is 1. Now what is the value? This value will go inside of the first flip-flop. First flip-flop value go to the second, second will go to the third, third will go to the fourth, fourth will be your output value. Now what it is replaced? It is replaced with the 1110, right? Same 1110. Now after applying the fourth clock pulse, what will be happen? This final one is there, right? This we are going to give here as the external input value. Here external input value are giving. Now what will be happen? The data will be going to the first flip-flop, first flip-flop data second, second flip-flop data third, third flip-flop data fourth, fourth will be output value. Now what is the final data we have? 1111. So final data will be stored in the flip-flop is 1111, right? So it means that serial means at a time we cannot able to store the all value. One at a time we are going to store the one value by another value. So for understanding, we will consider one more example so that you will be understanding easily. This example we will consider. So how to connect the one flip-flop with the another flip-flop? After applying the clock pulse, the output of the first flip-flop is connected to the second flip-flop input, nothing but the serial in operation, horizontal. It means that shifting also will be performed the horizontal only, because as per the given question, serial in, serial out we need to perform. It means that output of Q is connected to the input of the second flip-flop DB, output of the second flip-flop is connected to the input of the third flip-flop, then output of the third flip-flop, nothing but QD is connected to the input of the fourth flip-flop, right? So here serial in means what? We are giving the data externally. It means how many at a time, how many values we can give? Only one value. Serial means only one value. So this is the final flip-flop, right? Fourth flip-flop. So whatever the value which is coming out from the QD or fourth flip-flop, then it is called as the serial output value. If you observe here, this data we are collecting the serial only, right? So for example, initially we will consider some data. What is the data is 0 0 something 0 0 will consider. Now before applying anything, nothing but before applying anything, right? So my data is at 0 0 0. Here I am going to consider the clock pulse value. This is the initial clock pulse before applying the data, right? So let me consider here. So before applying the data, the value is 0 0 0, right? So let it be, this is the QD, then QC, QB, QA. It means that output of the first flip-flop, second flip-flop, third flip-flop, fourth flip-flop. So clock pulse is nothing I am going to apply. I am going to consider that all the flip-flop value which is stored in the 0 0 0. Now what my requirement is that I want to replace what? The data with 0 0 0 with the something. Previous example only we will consider so that you will understand. I want to replace with what? 0 0 0 0 with what? 1 1 1. So it means that at a time, so first we will apply the first clock pulse. After applying the first clock pulse only, count will changes or shifting operation will be performed. Now where we are giving the external data input? Serial, right? So this is the first flip-flop, right? Here only we need to insert the external data, right? So now this we will consider this value, right? So this data we are trying to insert into the first flip-flop. So now here what is the value we need to consider? 1. So the moment here we have the connection, right? If it is go to here 1, then what will be happen? So it will store 1, right? Then what about this 0 value? Because it can able to store only 1 bit information, right? Because already here 0, right? Now what will be happen? 0 will be shifted. The output is 0 is nothing but QA, right? QA will be shifted to here, right? Now already this is DB is there, right? Where it will shift? It will shift to the third flip-flop. Now already this 0 is, right? Where it will shift? It will shift to the fourth flip-flop. Already fourth flip-flop we have the value, right? Where it will shift? This is nothing but your final output value. See that how many outputs you are collecting? Only single output at a time, right? So this is what we called as the serial output. Now after inserting this data, what is happening? 1 will go to the first flip-flop, nothing but this one. Then this 0 will go to here, this 0 will go to here, this 0 will go to here. This is your first output value, right? So after applying the second clock pulse, what we can do? we can give the one more external input data, right? What is that value we are trying to give? 1, right? Now this value will be replaced with what? 1. The first flip-flop value will go to here, second will go to here, third will go to here. This is the final output value. After applying the one more clock pulse, if you see the third clock pulse, this external data we are giving, right, it will go inside of the first flip-flop. The data which is stored in the first flip-flop will go to second flip-flop will go to third flip-flop will go to fourth flip-flop is your output. Again, what is the one more data pending? 1 we need to insert. This will go to first flip-flop will data will go to the second one, second will go to third will go to fourth one is output value. So if you observe here, how many clock pulses are we required? 4 clock pulses. Why 4 clock pulses are required? We are performing the 4 shifts, right? So in order to replace the 0 0 with, what is the first step? 1 0 0, next 1 1 0 0, next 1 1 0, next final one 4. So to change this 1 clock pulse, to change this second one, to change this third, to change this 4. In exam point of view, they will ask the question, if my initial data is 0 0 0, right, I want to replace with something 1 1 1. Now you just tell me the what is the output value, right, at the second clock pulse, right? So like these questions may be expected in the exam point of view. Now question is that if my initial data in the flip-flop is something 0 0 0, after applying the second clock pulse, you tell me what is the output value. But that data which I am trying to replace 4 zeros with the 4 ones. Before applying the clock pulse, this is the value, right? Now we'll apply the first clock pulse. First clock pulse means what will be happen? This data will be insert, right? This will go to first flip-flop. First will go to here. It will go to here. It will go to here. This is your output value. Now after the first clock pulse, what is the answer? 1 0 0. Now at the second clock pulse, what we are trying to do? We are giving the one more external one, right? Now this will go to inside of the first flip-flop, right? The first flip-flop will data will move to the second one, right? Second one will move to third one will move to fourth one is output. Now at the second clock pulse, what is the output we are getting? 1 1 0 0. This is the answer, right? Now suppose given question is something like this, right? So let it be before applying the clock pulse value, right? So before applying the clock pulse value, the data which is stored in the flip-flop is something 1 0 0 0, right? So I am giving the replace with the external value is 1 0 1 1. For example, this data should be replaced with what? 1 0 1 1. They are asking that you find out what is the output after the second clock pulse, right? So after applying the first clock pulse, what will be happen? This data will go, right? So 1, this will go to second one, next 0 0. This is your final output, right? After applying the second clock pulse, what will be happen? This is the external value, right? See, always we need to take from LSB to MSB. Remember that one more important part. Now what will be happen? 1 1 1 0. Now what is the answer? 1 1 1 0. Now here what is the answer? 1 1 0 0. This is how depends upon the how they are giving the input, how they are asking to replace, then how many clock pulse they are giving. If they are asking to find out the third clock pulse, means what is the answer? So this 0 will go to here right now. Next this 1 will go to here. 1 1. This is your final output. So what is the answer for third clock pulse? 0 1 1 1 is the answer. So like that you need to find out. So remember, serial in serial output means data should be entered serially, data should be collected serially, but at a time you cannot able to replace 4 values one after another. At a time you cannot able to get the 4 outputs only one after another. That is the meaning of the serial input, serial output operation. In next classes we will see the remaining shift register operations. Thank you.